This is Jay, and I'm going to demonstrate for you guys today how to get started hacking around on your own Spark streaming application. So I'm going to grab my terminal. There we go. And you can see in this directory I've cloned down the source code for this Spark streaming application's GitHub repository, and I haven't done anything else, so we're going to start from scratch. So let's grab IntelliJ, and we're going to do import project. And we're going to go here, and we're going to pick SBT because this is the SBT project. If you haven't set up the SBT plugins in IntelliJ yet, then you can do that using I think I have a blog post on how to do that, which is right here. This is the general instructions for doing this on a Fedora box, but you can do this on a Mac or Windows or whatever. It's pretty similar. You basically are just going to install the IntelliJ IDE, and then you'll go to install these plugins, the SBT plugin and the Scala plugin and whatnot. Once you do that, you should be able to load any SBT based project. So in the last screen I selected the directory that might that my terminal was in, and let's get rid of this guy. Now we're going to go ahead and click SBT and hit next. And I'm not going to download sources and docs because that takes a while. But you may want to do that in your case. I'm just going to go with 1.7 here. I usually just go with the defaults unless everything blows up. Also, this assumes that you have Scala and SBT installed and working. There's plenty of resources out there on how to install and set those up. The best way to just confirm that you have a sane environment is you can do, SBT help. And you will get the help text there. So that's how you know you have SBT installed. So yeah, you want to have SBT installed to do all this. Actually I don't know, maybe IntelliJ magically installs it for you, but SBT is just a build tool for Scala. So anyways, when I click finish, IntelliJ is going to go ahead and start building the project. As you can see, it gets all the dependencies. There's a lot of dependencies, and while it gets the dependencies, for those of you that are new to Scala or new to SBT, we can just walk through and take a look and see all the dependencies it's getting. You're getting Spark. Scala test allows us to run unit tests. JUnit, we all know what that is. It's another unit test library. All the Spark stuff, MLlib, Spark SQL, Spark streaming, Twitter, the Twitter4j libraries. We're also importing the CTEX libraries. In particular, this example will have will show a couple of different ways that you can consume a Twitter stream and do different things with it. One of which is reading data in directly from from Twitter and applying CTakes, which is a medical text NLP library, to it. But also, we also have the DataStax Spark Cassandra connector, which we are also going to show how you can when read tweets in and just dump them into Cassandra, so that's pretty much the basis for a build file in SBT. It defines dependencies and tasks and whatnot, and you can build it from the command line by doing SBT test or SBT package or whatever. That will build you the jars. We're not going to worry too much about the command line yet. We're going to play around with running it in the IDE. Once I load everything up, you can see IntelliJ loads everything up really beautifully and nicely for you, and you can poke around in the source code. And the way the source code is organized is there's some general utilities for building a streaming app with Twitter, and then there's a CTake specific package, which is a full application. So for this demo, we basically go to the app, and in Scala, one thing to note for those of you that have a Java background, in Java, classes are the same as the files they're in. In Scala, that's not always the case. So in this case, I have it's an object called driver. This is another thing in Scala, which is you have this concept of a static object that you can just declare as the top level element in a file, and this is sort of similar to when you create a static object in a Java source file. It's a singleton. It'll just be created, and you can run it, and it's really good for example, for building like an executable class, an entry point to an application, which is what we've done here. So we've created an object called driver, and we can run this object in IntelliJ. Just run driver, just like that. And let's walk through the code. Well, first, before we walk through the code, let's run it and make sure everything works. So I'm going to make my window a little smaller so you guys can see everything. Okay. Here we go. All right. Here's the terminal. All right. Actually, we won't need the terminal because we're just going to run this directly. So, I can right-click on this class, and then I can just do run driver. And before I run driver, there's one thing you need to do to run this, which is you need to set up Twitter credentials. So, these are my Twitter credentials. I won't have them all on the screen at once, but I just created this file, temp.twitter, and it has to be like key value pairs, which is like consumer key equals this, consumer secret equals that, access token equals that, access token secret equals that. Don't bother trying to steal these because I'm going to refresh all these and delete these credentials after this. Anyways, so blah 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 blah. So here we go. Now let's run this guy. So I can just do, like I said, run driver, and when I run the driver, it will it will use some reasonable defaults for me if I don't specify arguments. So it'll use a temp output directory path. It'll only read in 10 tweets. It'll only have one partition, and the intervals for outputting the RDDs will be 10. So okay, let's go for it. So you notice that originally when I start this thing, this guy is gray because we haven't run anything yet in this project, but eventually it'll turn green, and you can have your little shortcut button to run this from there afterwards. So it's compiling, and you can see that at the bottom it's doing some work, and looks like it's working just fine. So we can see it's read in all the credentials, and it printed them out to screen. That's probably not the best idea from a security perspective. Anyways, a couple of exceptions that at this point we can't ignore. And we can see that we are indeed streaming in some tweets. So Microsoft holograms, cool but unfinished. A new frontier for medical care and medical simulation. So these are all medical related tweets that we're streaming in. So you can see that we indeed streamed in a bunch of Twitter data, and we can see that there's a debug statement that we put in here running a Cassandra insert. So let's go ahead and take a look and see what was going on there. So this worked, just to be clear. Everything worked. Spark context was stopped. And now let's kind of go into the details of how it all works. Like I said, the application is here, so we start tracing from here, and we can see in the driver, there's really kind of one method where we have all of our application logic, and that's this start stream method. We create a Spark configuration. We use local 2. That means that we're going to have 2 threads, 2 workers essentially in local JVM. And what that means is what we need, the reason why we have 2 here is because for a Spark streaming job, you'll have a consumer and a producer. The producer, the D streams, have their own producer, and they're going to keep pumping out tweets once they connect to Twitter. And then you will have a consumer, essentially a task that's going to be sent to Spark Master to be run every n seconds, which will consume those tweets and do something with them. So there's a little bit of an abstraction here. It's a Twitter application template that I've written, which makes it really easy to write Spark jobs that use Twitter. And in this case, we simply call this method spark start stream on it. We send it our configuration. We send it a function which creates our D stream. And then we send it another function. So in Scala, you can send functions as parameters. That's why this kind of looks kind of funny. So for those of you that have done any functional programming before, and we send in another function which takes a transaction and a Spark configuration, and this is a way essentially in Scala of defining a function which takes arguments anonymously. So it's an anonymous function which essentially can be called as long as you send it 2 arguments, and the arguments will be we'll name them transactions and Spark configuration. The reason that these don't have types associated with them is because the Spark start stream function, in its method signature, you can see that it has a third argument, which is a pluggable function, which is an array of Twitter statuses and a Spark configuration as inputs and returns a Boolean. So that function in here, okay, tells Scala the type that if I'm running start stream, then the third argument is going to be a function which the first input is going to be an array of statuses and the second input is going to be a Spark configuration. And so in this case, it's so Spark already knows the types of these, so I can just give them names, transactions. I could just as easily call this X if I wanted to, and I could do X dot, and I could do all the things that that I want with X. So I could name these parameters wherever I want. In this case, I've named it transactions, and really this should be called statuses, so I'll change that right now. Statuses, right? And we'll do statuses for each. Okay, and so this is the function body. So in this case, what we're doing is we're calling Cassandra, and inside Cassandra, we give the Cassandra connector a Spark configuration object. The reason we do that is because the Databricks library has actually adds bindings for Spark in it, But for your, if you were, for example, doing this in MySQL or something, you may have some other way. Um, you may not actually even need a Spark configuration at all. You may just have an IP address that you hard code in here or whatever. So this is, like I said, so this is just a function, and all this function does is it says, okay, every time you get 10 tweets or whatever, run this function against those. So what we do is basically for each of these Twitter statuses, we print a little debug statement, and then we go ahead and insert, run an insert. So this didn't fail because it's an asynchronous call to Cassandra. So this would allow you to do really fast inserts if you did it. If you did it this way, but you don't have to do an asynchronous. You can do an execute, a synchronous execution, just the same. Because I don't even have Cassandra running on this. But anyway, so this is one way that you can use this. Now, say you didn't want to use Cassandra at all. Say instead, this is just an example of how we would use this app to do something different with Twitter. Say you didn't want to do anything at all. Okay, you could just return true. So here's another little Scalaism for you. You don't have to have return statements everywhere. You can just do this. You can just have a Boolean. You don't need to have a return. So you could just do that and you would do nothing. Or you could do something a little different, which is you could use the ctakes API, the Apache ctakes API, which is what I'll show you an example of now. And you could say, for example, print out the result of, I have a utility class that I have here called ctakes term analyzer and analyze. And it's just wraps some calls to an NLP library that extracts some structured information from text. And I could say, I just want to analyze the, get rid of this. And I could just say statuses dot for, oops, I made a mistake here. Let me get back to where I was. Yeah, I could say statuses dot for each. And right here, oops, sorry, get text. Okay, so I can say I want to print out the result of analyzing this Twitter text, and now I can go and just so you see this. This is really just a wrapper to the ctakes API that I've created that allows you to just confirm that everything's working and connected properly. So when we call this analyze function, it returns the iterator of all the all the tagged parts of speech and whatnot that we build a pipeline for here. Okay, cool. So so this demonstrates now. So now we can basically rerun this entire application, and it does something completely different. Rather than taking these tweets and dumping them into Cassandra, we're taking these tweets and using them and running an NLP library on them to analyze the parts of speech and whatnot. So let's see. Let's put something easy to find in our debug here, since we got all these logs coming out. And let's run it again. All right, so we can see here that this time around we rather than just dumping these things into Cassandra, we could see that the results of a CTAKES analysis. Oops, there we go. Yep. Are being printed out to screen here. So we could see each term has associated with it a part of speech. And so that's how you use this little framework for writing Spark streaming applications. That's how you run this from IntelliJ. That should serve as a pretty easy to adopt kind of a template for building Twitter-based applications. Obviously, any Scala code you could put in here, so you could just as easily put in Scala code to, for example, store these things as a text file. So you could do anyways, my fault. These are actually arrays. And again, we can confirm, so I can't directly save them in the file. So we can see here that that function, which is being called, is being called against an array of tweets. We may want, if we wanted to change this so that we sent it the actual RDD instead of the array of RDDs, then we could get rid of this collect, and then we'd be able to well, we'd actually have to change the we'd have to change this type signature too and whatnot, so we're not going to do that. But anyway, so this takes in an array, so you'd have to write those array elements to disk. And so that's not the best design. We'll need to fix that in the future. But yeah, that's the that's an introduction to and that's it. Go here. Stop that. Actually, there's one other thing we need to do. There are actually other things we should do, which is we should also show how to run this as a jar as opposed to running it from the IDE. So if I run sbt package, you can see first thing that happens is all the dependencies get resolved. Okay, and we can see that we have a jar here that's created. So there's no manifest attribute, obviously, so we need to give a main class when we run this. So we do that by doing the Java CP action, and that will add this jar to the class path. Actually, I have a template in here, right? So we can do. And now we put the class name in here. So we go back to our original driver class and let's find it. Wow, it looks like I accidentally ran it. Didn't mean to do that. Let me kill it. Okay. And let's find the name of the driver. Okay, here it is. So that's Spark Apps, C takes, driver. Okay. And because Scala isn't on the class path, it died. So let's build the let's rebuild the jar file, but this time let's rebuild it and bundle the dependencies. Okay, so I left, took a little break because I was running into some issues. Building a jar, and I fixed those issues. What I did is I added a merge strategy to my SPT file here, and that merge strategy will allow us to merge in jars with duplicate. Just some duplicate contents in them in a smart way. And also I installed the SPT assembly project, which plugin. And the way you do that is you put a plugins.spt file in your project directory, and this allows you to run a dependency graph, so you can see all your project's dependencies. And this plugin allows you to run SPT assembly, which builds a single jar. So now we are able to, and I will be committing these. So, let's see what we've changed here. We'll add our build.spt, and we'll add our project plugins.spt. Now the source should be updated to allow you to build a fat jar. So let's find that jar in here. So this command is, let's see, find dash name star jar, see what jars have been created. And this is the jar. So we can see what classes are in a jar by doing jar-tf. And let's grep out for the ctakes. We'll grep for the drivers. Okay, and we can see that our Spark Apps.ctakes driver class is in the directory tree, and that should be good enough for us to move forward. So now we can do history, grep jar. Now we can try again the second time. No guarantees here that this will even work. We'll see. And it almost works with the exception of an Akka error, so let's debug that. left off with some build issues, and in order to fix them, I had to go into my actually with the jar. And the issue with the jar was that it was unrunnable because certain jars weren't being bundled. So to fix that, I added the SBT assembly plugin. So I'll show you guys how I did that. Project plugins.sbt, and assembly allows you to make a bundle jar file that has all your dependencies in it. After I added the assembly plugin, I also did one other thing, which is I created this thing called a merge strategy. A merge strategy, really you don't need all this. I borrowed this as a template from something I found online, but what I really needed is to find a way to merge this reference.conf file, because there's more than one source of that file in existing jar files, and the Akka specific parameters for reference.conf. Akka is an actor library that Spark uses. Those parameters need to be in, so I was able to do merge strategy.concat. So what that does is it just allows you to merge the contents of two files from two different jars when you build the final jar file. And now, after I ran, so then now what I could do is I could build a jar using SBT assembly. So this assembles a big, huge executable. And you can see it running now. And it takes a while. And in the end, looks like it didn't show up at the bottom of the screen, so I'll move my screen up. In the end, you get that. So you can see the jar there. So again, we defined dash name star jar. And we can do jar dash tf, which will show you all the classes in the jar. A very important trick on this guy. And we can see we got everything in here. We want to make sure that some of our code is in here. We can grep for driver, because as you remember, there's a driver class, and you can see again our driver class is in here. And now we can test this. This is the cool part, right? Now we can test our application locally by just running this command. So we do Java and we do -cp. So this puts this jar on the library class path, and then we give the class name, which is spark.apps.ctakes.driver, and run that command, and we can see that we can now actually run this jar directly. And we can see, we'll be able to see in a minute, tweets start coming in and whatnot. Let's see. Let's go here. Okay, so there we go. We can see child infant 4 wins with Columbia and blah blah blah. I don't know what that tweet means, but anyways, the point is that we we are able to get information, and now it's somebody else's job to figure out what that information means. And that's it. So that's how you build, edit, and deploy a jar file for a Spark streaming application locally. You can there are some issues with this, obviously, for deploying to a cluster. Like, I hard-coded the local parameter, so I should show you really briefly that cool. We set the master, we hard-coded it in here. That's obviously something we're going to want to change in this, and we're going to add that to, we're going to want to add the master as a argument to the main method. In other words, we're going to want to add that in here so that we can run this on a cluster. But otherwise, this is pretty much a complete round trip of how you build, deploy, edit, and so far and so on a particular a Spark streaming application. If you run this tutorial, by the way, all the way through, there's one issue, which is that in this jar file, I haven't bundled all the ctakes stuff properly, so we run into some class path errors. And I haven't actually looked into that entirely yet, but I'll fix it later on. So just to let you know, if you run this, it'll run infinitely because these stream consumers wind up crashing for some reason. But otherwise, it should work, and obviously for the Cassandra stuff, it will work perfectly because we're not having that error for any dependencies there. So yep, that's it. Thanks for watching.